Put an American Jeep on trestles in a German workshop in 1942 or 1943, strip it down to the frame, and the first surprise is how little there is to discover. The engine is conventional, the steel is ordinary, the suspension is old-fashioned. The body is little more than flat panels welded into a box. Nothing inside requires a secret alloy, a revolutionary machine tool, or a piece of engineering that German industry could not understand. That creates the real puzzle. If Germany could manufacture every part of the Jeep, why could it not reproduce what the Jeep was doing for the American war effort? The answer begins before the vehicle had a name, in a procurement problem the Army could no longer ignore. In 1940, the United States Army wanted a light reconnaissance vehicle to do jobs the motorcycle and sidecar could not do once roads disappeared and the ground turned soft. The requirement was demanding: four-wheel drive, a useful payload, a low silhouette, a folding windscreen, a track width that matched existing ruts, and a weight target so aggressive that it forced designers to question almost every unnecessary pound. The Army sent the request to 135 manufacturers. The deadline for a running prototype was 49 days. Only 3 companies answered seriously: Willys Overland, Ford, and the American Bantam Car Company. Bantam was the unlikely one. It was a small Pennsylvania manufacturer with little money and almost no engineering staff left. It brought in freelance engineer Carl Probst, who laid out the vehicle at extraordinary speed. Bantam delivered a working prototype to Camp Holabird inside the deadline, and the basic idea survived Army testing. Then came the part that made the Jeep less a story about one brilliant inventor than a story about a government preparing for industrial war. The Army did not believe Bantam could build the vehicle in the quantities a major conflict might require. Its design information was made available to larger competitors. Willys produced a version with a stronger engine. Ford produced its own version and, more importantly, brought enormous manufacturing capacity. The standardized vehicle that emerged drew from the work of all 3 companies. Willys built the MB, Ford built the GPW. Bantam, which had done so much to make the concept real, received only limited vehicle production before spending much of the war building trailers. There is an uncomfortable truth inside that history. The company that proved the idea was not the company that received the biggest share of the reward. But the Army was optimizing for a different problem. Not who deserved ownership of the idea, but how to put a useful machine into the field by the hundreds of thousands, and that changed the engineering. The original weight target was close to impossible and was later relaxed, but its pressure remained in the design. Every part had to defend its existence. Comfort had almost no vote, decoration had none. That constraint did more than make the vehicle small. It forced the Army and the manufacturers to decide what a military car actually needed. Four-wheel drive stayed because traction mattered. A useful payload stayed because reconnaissance was only one of the jobs the Army expected the vehicle to perform. A folding windscreen and low body stayed because a high enclosed cabin would add weight and make the vehicle harder to conceal. The specified track width tied the vehicle to roads and wheel ruts already being used by other traffic. Blackout lighting belonged to the realities of an Army that expected to move at night under threat from enemy aircraft. Seen separately, none of those decisions was revolutionary. Together they created a machine shaped almost entirely by use. That is why a parts list gives such a poor explanation of the Jeep. The intelligence was concentrated in the choices about what not to add. The Willys engine, the 4-cylinder unit soldiers came to know as the Go Devil, produced roughly 60 horsepower from about 134 cubic inches. Its side valve layout was already conservative technology. That was part of the point. It did not need to impress an engineer. It needed to start, pull, survive abuse, and be understood by people far from a factory. The frame was simple. The suspension used leaf springs. The body relied on flat steel surfaces. There were no doors, no proper roof, and no effort to make the vehicle refined. Sophistication had been treated as a cost unless it directly improved the job. That same logic appeared when the Jeep broke. A wartime vehicle could not assume a trained specialist, a heated garage, or a complete tool room. It had to be repaired wherever the Army happened to stop. The Jeep's engine bay left room for hands and tools. Common service items were accessible. Fastener sizes were kept relatively simple. The machine could be understood without first dismantling half of it. Whether or not anyone wrote the design brief in these exact words, the vehicle behaved as if its engineers had asked a harsh question. Can a young soldier with limited mechanical experience get this thing moving again tonight? That question matters because a vehicle that is magnificent in a workshop can become useless in a mobile war if the workshop is 200 miles behind it. The Jeep could also be broken down for shipment and reassembled at its destination. It could be towed, carried, loaded into transport, and moved in ways that made its small size part of the logistics system rather than merely a driving characteristic. But maintainability alone was not the hardest thing to copy. The harder thing was standardization. Ford did not simply build a Ford light car that resembled the Willys. Ford produced the standardized Jeep to the same basic specification. Parts were intended to interchange across vehicles from the two manufacturers. That sounds mundane until a war turns distance into a daily emergency. A mechanic does not care which corporation built the damaged vehicle if the replacement axle in the depot fits. A supply officer does not want 10 versions of a simple part if one version can serve thousands of machines. A unit on the move does not need engineering elegance. It needs certainty. Interchangeability turns that certainty into time. A broken vehicle no longer has to wait for a component made by the same factory that assembled it. A depot can stock deeper quantities of fewer parts. A mechanic learns where components are located and how they come apart, then applies that knowledge again. Training becomes reusable. Manuals become reusable. Tools become reusable. Salvage vehicles become more useful because their surviving parts can support other machines of the same standard. This is easy to overlook because no single step feels dramatic, yet each one removes friction. And in a war of movement, friction consumes hours, trucks, rail capacity, workshop space, and human attention. The value of a standardized vehicle is not only that it is cheaper to build, it is that thousands of small decisions downstream become simpler. And this is where the Jeep becomes a story larger than the Jeep. Germany entered the war with a very different vehicle problem. German industry had produced many models, and conquest added still more. French, Czech, Austrian, Belgian, Dutch, Italian, and other vehicles entered military service, each bringing its own parts, tools, manuals, and maintenance demands. Germany understood the danger. Before the war, Adolf von Schell was given authority to rationalize vehicle production and reduce the number of types. The effort cut the range of German-built models, but wartime expansion kept adding foreign fleets faster than rationalization could fully simplify the system. So a German formation could possess many vehicles and still suffer from a shortage of the one component needed to return a particular truck or car to service. Conquest made that contradiction worse. Captured transport was useful because Germany needed wheels, but every new make could also create another maintenance chain. A truck could be perfectly serviceable on the day it entered German use and become a liability months later when a specific bearing, gasket, electrical part, tire size, or workshop instruction was no longer easy to obtain. A vehicle fleet that looked large on paper could therefore demand a disproportionate amount of sorting, cannibalizing, improvisation, and local knowledge to keep moving. This did not mean German mechanics lacked skill. In many cases, the opposite was true. Skill was being spent compensating for variety. American standardization tried to spend less skill on discovering what a machine needed and more time simply returning it to service. It also meant that a lesson learned in one workshop could travel with the fleet instead of remaining tied to one make and model. The American system attacked the opposite problem. It accepted a machine that was not the best answer to every technical question, then repeated that answer on a scale that simplified training, parts, repair, and replacement. By the end of wartime production, Willys and Ford had built roughly 640,000 Jeeps. Germany's own light military car proves why that number matters. The Volkswagen Kübelwagen was not an inferior machine in every respect. It was very light. Its air-cooled rear engine eliminated the radiator, coolant, water pump, and hoses that could create trouble in severe cold. Its ground clearance and low weight gave it real advantages in difficult going, and its simplicity made sense for military use. Germany built roughly 50,000 of them. The amphibious Schwimmwagen was even more specialized and ingenious, with four-wheel drive and a folding propeller. Roughly 14,000 were produced. The Jeep, by contrast, offered four-wheel drive, more power and torque, useful towing capacity, and a broader range of jobs. It was heavier, and in some conditions that weight was a disadvantage. It was water-cooled, which meant it carried components the Kübelwagen simply did not need. So the lesson is not that the American vehicle was technically superior in every environment. It was not. The difference was that the United States made one broadly useful answer so abundant that soldiers stopped treating it as a special piece of equipment. Once a machine is everywhere, doctrine begins to bend around it. The Jeep carried officers and scouts, which was close to its original purpose. Then units used it to carry radios, ammunition, tools, and machine guns. It towed light guns and trailers. Reels could be mounted so signal troops could lay telephone wire while moving. In North Africa, British Special Air Service troops adapted jeeps into armed raiding vehicles. Elsewhere, litter racks turned them into improvised ambulances. That medical role shows what abundance does better than almost any other example. A litter does not move itself. Before a wounded man reaches surgery, somebody has to carry him away from the place where he was hit, transfer him to an aid point, and keep moving him through the medical chain. Terrain, distance, and time all work against that process. A small vehicle that can get closer to the front than a large ambulance does not solve battlefield medicine, but it can remove one critical delay. The Jeep's value came from being available often enough to make that option routine rather than exceptional. The same principle applied to communication. Telephone wires still had to be laid. Radios still had limited range and reliability. Commanders still needed to move between positions. A Jeep did not invent any of those systems, but it reduced the physical time required to connect them. That is what a force multiplier often looks like in practice. Not a spectacular new capability, but less delay between one useful thing and the next. A vehicle does not need to destroy an enemy to multiply combat power. If it shortens the time between a wounded soldier and an aid station, it changes survival. If it lets an officer reach another unit faster, it changes command. If it carries a radio or a cable team farther in an hour, it changes information. If it moves ammunition before a position runs dry, it changes what every weapon around it can do. The Jeep increased the usefulness of systems that already existed. And because it existed in such numbers, that multiplication happened across the Allied war effort at the same time. The vehicle kept collecting jobs its original specification had never listed. Jeeps were fitted with flanged wheels to run on railway track where locomotives or rail equipment were unavailable. Some carried blades for clearing snow. Others became mobile platforms for chaplains, correspondents, mechanics, medics, and commanders. War correspondent Ernie Pyle described the Jeep in terms that captured this everyday usefulness. A machine that seemed to do almost everything and go almost everywhere. That kind of praise can make the Jeep sound magical. It was not. It was cramped. It was noisy. It exposed its occupants to weather and fire. It could be overloaded. It could break. Its advantages did not erase terrain, maintenance, fuel, or the vulnerability of an unarmored vehicle near combat. Its strength came from something less dramatic. When one broke, another could exist nearby. When a part failed, the supply system had a reason to stock the same replacement in quantity. When a soldier learned one Jeep, that knowledge transferred to the next. When a factory improved the flow of one standardized component, the benefit multiplied across a huge fleet. The value of the vehicle and the value of the system reinforced each other. This is why dismantling a Jeep could be misleading. A German engineer could measure its wheelbase, copy its suspension, reproduce its engine output, and draw every bracket on the chassis. None of that would reproduce the network that made the vehicle powerful. The network included standardized drawings, factories willing to build the same basic machine, common parts, depots, shipping capacity, mechanics trained around a limited family of components, and an economy capable of replacing losses without treating every vehicle as irreplaceable craftsmanship. That is a different form of engineering. It is engineering at the level of a system. The Jeep also carried a cost inside that system. Bantam's experience showed that industrial mobilization could reward scale more than invention. Standardization meant accepting compromises rather than perfecting a unique solution. Mass production could make an adequate design more strategically useful than a technically elegant design produced in smaller numbers. Those compromises were not accidents around the Jeep. They were part of what the vehicle represented. After the war, the shape proved durable enough to escape the military system that had created it. Willys moved quickly towards civilian versions. Surplus Jeeps remained in countries around the world. In Britain, the experience of using a wartime Jeep helped inspire the Land Rover that appeared in 1948. But the wartime significance came first. The Jeep did not dominate because German engineers were incapable of understanding it. They could understand almost everything they saw. The harder problem was reproducing the invisible part, the decision to accept simplicity, lock down a standard, make competing factories serve that standard, organize parts around it, and then manufacture enough copies that the vehicle became ordinary. The Jeep was ordinary by design, and at wartime scale, ordinary was the advantage.